Hi guys, so today we'll be solving a question on wave equation. We're solving a question on wave equation. So the question says the equation of the wave traveling in a horizontal direction is expressed as y equals to 15 sine 2 all over 5 bracket 60t minus x. They say we should find the wavelength. They say what is the wavelength? What is the wavelength? What is the wavelength? Now, before I proceed, welcome to Concept Mastering, and please subscribe on the subscribe. Please just click on the subscribe button. Please click on the subscribe button, and also like and share my videos. Now, the very first thing is just to compare it with the wave equation that looks exactly like it. There's a wave equation that looks exactly like it. In my previous videos, I've seen many waves equations and also show you how to derive many of them. So the one we are going to compare it with is our y equals to a sine bracket 2 pi x all over lambda minus 2 pi t exactly. So we are comparing it with this one. And which one will we give you? We are giving you are giving our y equals to 15 sine 2 all over 5 60t minus x close the brackets. So we are comparing this with this one we were given. Now the very first thing is you're going to multiply this 2 all over 5. You're going to multiply it with the brackets. You'll make it go inside the brackets. That means we're going to have our y equals to 15 sine 2 all over 5 times 60 t will give us 120t all over 5, and 2 times minus x will give us 2 all over 5x exactly, 2 all over 5x. Now we are asked us to find the wavelength. The wavelength and the wavelength here is actually our lambda. Now in our equation here, the one we are comparing with, you see this way, you see where the lambda is actually under 2 pi x all over under 2 pi x. This way this lambda is. Now if you now trace it to the given equation we are given, which one looks exactly, which one do this x fall in? It's actually here. You can see lambda is under x, so you're going to compare it with this one. You're going to compare it with this one. Since lambda is under x, this is what you're going to compare it with. So we're going to have our 2 pi x all over lambda will be equals to 2x all over 5. Now listen, you don't carry the minus sign. You don't carry the minus sign. Why do I say so? This minus sign only shows that the wave is traveling either in a positive direction or in the negative direction. In this question, it means that the wave is traveling in the negative direction, so you don't need to carry the sign there. You only just carry the figures, the coefficients, and here, and the letter itself. That's what you're going to compare with. I know you are not comparing with this one. You are not comparing this one, because if you see here, we're only comparing with this one, 2 pi x over lambda. That means you're going to compare with only 2x all over 5. So don't make any mistake. You're only comparing the one that's look like it. So the remaining rest, you just leave it alone. So this is the one you're going to compare now. Now, if you in this one now, you see that we have 2 here, we have 2 here, we have x, we have x. What are we going to do? They will cancel each other. 2 we cancel 2, x we cancel x. We are left with pi all over lambda and 1 all over 5. So we're going to do cross and multiply. Therefore, our lambda will be equals to 5 times pi. Yes, 5 times pi. and our lambda will now be 5 times pi is actually 22 all over 7. So when you times this, we have 15.7 meters. 15.7 meters. 15.7 meters. And that is actually our answer. So thank you very much for watching, and please don't forget to subscribe and like my videos. And have a wonderful day.